Welcome back to the channel. Today, we're tackling a fundamental concept in the world of cryptocurrencies and decentralized technologies: blockchain. You've probably heard the term thrown around, especially when talking about Bitcoin or other cryptocurrencies. But what exactly is a blockchain, and why is it so important? In this video, we're going to break down what a blockchain is, how it works, the technology behind it, and its applications beyond cryptocurrencies. By the end of this video, you'll have a comprehensive understanding of blockchain and why it's considered a revolutionary technology. Let's get started. At its core, a blockchain is a decentralized digital ledger that records transactions across a network of computers. The term blockchain is derived from its structure. Data is stored in groups known as blocks, which are then linked together in a chain-like fashion. Each block contains a list of transactions, a timestamp, and a reference to the previous block in the chain, creating a continuous, unalterable history of transactions. The decentralized nature of blockchain technology means that no single entity controls the entire system. Instead, it is maintained collectively by the network of participants. This provides a high level of security and transparency because the data stored on the blockchain is open for everyone to see, but impossible to alter without the consensus of the entire network. The concept of blockchain was first introduced in 2008 by an anonymous person or group known as Satoshi Nakamoto, who used it as the underlying technology for Bitcoin, the world's first cryptocurrency. Since then, the idea has expanded far beyond digital currency, with blockchains now being used for various applications across multiple industries. But before we dive into the different use cases, let's first understand how a blockchain actually works. The functioning of a blockchain can be broken down into three main components: blocks, nodes, and miners. Blocks are the basic units of a blockchain. Each block stores a set of transactions, a timestamp indicating when the block was created, and a reference known as a hash to the previous block in the chain. The hash is a unique identifier generated by running the contents of the block through a cryptographic algorithm. Any change to the block's data would result in a completely different hash, which is one of the ways blockchain ensures data integrity. The first block in a blockchain is called the Genesis block, and it serves as the starting point for the entire chain. Nodes are the computers that participate in a blockchain network. Each node maintains a copy of the entire blockchain and follows a set of rules known as the consensus protocol to validate new blocks and transactions. The decentralized nature of blockchain is achieved by having multiple nodes that independently verify and record transactions. This means that even if some nodes go offline or are compromised, the network can still function securely because other nodes can maintain the integrity of the blockchain. Consensus mechanisms such as proof of work, POW, and proof of stake, POS, are used to ensure that all nodes agree on the state of the blockchain. Miners play a crucial role in blockchain networks that use proof of work as a consensus mechanism. They are responsible for verifying transactions and adding new blocks to the chain. Miners compete to solve complex mathematical problems, and the first one to solve the problem gets to add the next block to the blockchain. In return for their efforts, miners are rewarded with cryptocurrency. This process, known as mining, is what keeps the network secure and prevents fraudulent activities. While mining is essential for networks like Bitcoin, other blockchains may use different methods, such as staking, to validate transactions. The primary advantage of blockchain technology is its ability to provide security and transparency without the need for a central authority. Traditional systems rely on intermediaries, such as banks, to facilitate transactions and maintain records. However, these intermediaries can be slow, expensive, and vulnerable to corruption. Blockchain eliminates the need for intermediaries intermediaries by allowing peer-to-peer transactions directly on the network. Every transaction on the blockchain is time-stamped and recorded on all participating nodes, making it extremely difficult for any single party to alter the records without being detected by the entire network. Blockchain's immutability is another key feature. Once a block is added to the chain, it cannot be altered without changing all subsequent blocks, which would require the consensus of more than half of the network's participants. This makes it practically impossible to tamper with the data stored on a blockchain. For this reason, blockchain is often referred to as a trustless system, meaning that users do not need to trust a central authority because the network itself guarantees data integrity. The most well-known application of blockchain is, of course, cryptocurrencies like Bitcoin, Ethereum, and others. Cryptocurrencies use blockchain to maintain a decentralized ledger of all transactions, ensuring that no single entity controls the currency. This has led to the rise of digital assets that can be transferred globally without the need for traditional banking systems. But blockchain's potential goes far beyond digital money. It can be applied to various other industries, from supply chain management to healthcare and even digital identity verification. For example, in supply chain management, blockchain can be used to create a transparent and tamper-proof record of a product's journey from manufacturer to consumer. By recording each step in the supply chain on a blockchain, companies can verify the authenticity of goods, prevent counterfeiting, and ensure that products meet safety standards. Similarly, in the healthcare industry, blockchain can be used to securely store patient records, giving patients more control over their data and making it easier for medical professionals to access accurate information. Smart contracts are another powerful use case for blockchain technology. A smart contract is a self-executing contract with the terms of the agreement directly written into code. These contracts automatically execute when the conditions are met without the need for intermediaries. For instance, a smart contract could be used to automate the release of funds for a freelance job once the work is submitted and verified. This eliminates the need for escrow services and reduces the risk of fraud. However, blockchain is not without its challenges. One of the main criticisms is the energy consumption associated with proof-of-work consensus mechanisms. Mining requires a significant amount of computational power, leading to concerns about environmental sustainability. Some blockchain projects are addressing this issue by transitioning to more energy-efficient consensus methods, like proof-of-stake, which does not rely on mining. Scalability is another challenge. As blockchain networks grow, the number of transactions that can be processed per second becomes a bottleneck. While solutions like Layer 2 scaling techniques and sharding are being developed to address this issue, achieving a balance between scalability, security, and decentralization remains a complex problem. Blockchain's impact on society extends beyond technology and finance. It has the potential to reshape the way we interact with data, trust institutions, and conduct business. For instance, blockchain-based voting systems could improve electoral transparency and reduce the risk of fraud. In the realm of social media, blockchain can enable decentralized platforms that give users more control over their content and personal data, challenging the dominance of centralized tech giants. The evolution of blockchain technology is still in its early stages, and we are likely to see new innovations and applications emerge in the coming years. As developers continue to explore its possibilities, blockchain has the potential to become as transformative as the internet itself, ushering in a new era of decentralized solutions that could change the way we live, work, and interact. If you found this breakdown of blockchain helpful, don't forget to like the video and subscribe for more crypto content. Let us know in the comments what aspects of blockchain you'd like to see covered next. Thanks for watching, and see you in the next video.